Okay, I was asked in class to kind of give a review of how to graph piecewise functions. So this is an easy one. We'll take a look at this. And we're going to use a parabola when x is less than or equal to 1, just x squared, and y equals 2 when x is greater than 1. So what we'll do is the function that we want to do piecewise, we'll put a parentheses around it. So we'll just put parentheses, and then we'll graph x squared, or put x squared in, x squared, parentheses, and then I'll put a parentheses for my restriction next to that. So what's my restriction? It's going to be x less than or equal to 1. So I'm going to write x, or hit x, and now how am I going to get the less than or equal? Well, I'm going to go to test, and test is under math, so it's second math, so I'll hit second math, and I get test, and that's how I'm going to get my inequality signs, and I want less than or equal, and that's all the way down to 6, so I go all the way down to 6, or I could just hit 6, and press enter, and that puts the less than or equal, and then I want 1, and I press parentheses, and there's the restriction. And I can graph that right now if I want, and I can go to zoom 4, I guess. And there's your parabola, and it stops. Now this is a little hangover line, just comes right down. On the Inspire, you don't have that. Some of the nicer calculators or the newer calculators, you don't have that, so it will just stop there. But it's kind of like a little, kind of just a edge line that these calculators put in. Okay? Okay, then let's put in the other part, and this is going to be 2. So again, I'll put a parentheses around the 2, and then a parentheses, and then x, and I'll put my restriction, and I want my x to be greater than 1. So I'll put greater than 1. How am I going to get greater than? It's going to be test, so I'll go second test, and greater is number 3. So I can press 3, and that puts it right in there. So that's nice. And then I want that to be greater than 1. And there we go. And then I can graph the whole thing. And there's your parabola. And then here's your x, or your y equals 2 for x is greater than 1. Again, we still have that drop-down line. So this is the problem because you don't have vertical lines and functions, so that actually shouldn't be there. So you should see that your graph goes like this, and then we have a jump discontinuity to 2. All right? So you have to kind of, and like I said, if you had an Inspire or some of the newer calculators, they don't show these, so you would actually see the jump discontinuity of the break. Now, if we wanted to make this a continuous function, we would have to make this 1, because this is when x is 1, y is 1. In other words, the value of x squared when x is 1 is 1. 1 squared is 1. So if I make this 1, it's going to be a continuous function. So let's go back, and let's just change that to 1, and then we'll graph it. And there's your parabola, and and you see we're connected. So now we have a continuous function because the height at the juncture point is the same. This height is, I'll change this, pardon me. Change this to 1. So now the height at the junction point is 1. Okay, because x squared when x is 1 is 1, and 1 is always 1. Unit up, that's y equals 1. So this is y equals x squared, and this is y equals 1. Now, okay, I'm sorry, let's see that there. And when x is 1, 1 squared is 1, and y is always 1. So the height is 1. So you can see we have a nice continuous function. Okay? So I hope that helps. And I think I did some of these on some of the other problems at the end of section 2.3. Okay?